Hi, and welcome to day 3 of functions. Today we're going to talk about different types of functions. Most of these functions you're familiar with, at least somewhat. Others you'll be very familiar with, and a few will be brand new to you. So the first thing we have is a linear function, and with a linear function, you see the word line in it. So a linear function is just a line. And you know it as y equals mx plus b. And to use function notation, since we are talking about functions, we would say f of x equals mx plus b. And yesterday in the notes, we talked about the fact that f of x and y are interchangeable. They mean the same thing. So an example would be y equals 1/2 x plus 5, or f of x equals 1/2 x plus 5. The domain for any line is all real numbers, because there isn't one number that I can't include in the domain, and the range is also the same, because lines go on forever and ever. So all real numbers for the range. A constant function is a horizontal line. Okay. Okay, so it's a horizontal line for a constant function. That's in the form y equals b, or f of x equals b. Just b is some constant. So an example would be y equals -4, or f of x equals -4. For this, my domain is all real numbers, because I can't restrict the x values in a horizontal line. I use all of the x values there are. The range, however, in a horizontal line, my y values are all the same. So whatever the b value happens to be, that is what your range is going to be. Okay, next is the quadratic functions, and this is a parabola. Okay, and parabolas are in the form of y equals ax squared plus bx plus c. So in function notation would be f of x equals ax squared plus bx plus c. And this is true as long as a is not equal to 0. If you put 0 in for a, then you get rid of your x squared term, and it's no longer a quadratic function. Okay, an example here, I'm just going to use function notation, because I think you can see that they're both the same, y equals or f of x, is f of x equals 3x squared minus 2x plus 7. Okay, and my domain would be all real numbers, because I don't have any restriction on my x value. My range will vary. It varies, and in order to find it, you need the vertex. Vertex of the parabola. So, for example, if I have a parabola that looks like this, and this is the point 0, 2, for this one, my range would be y is greater than or equal to 2. because it has from my very bottom values too, it keeps going up. If I happen to have a parabola that looks something like this, and that is the point, maybe 2, -2, or -1 we'll use since it came out as -1. For this one, my y values would be less than or equal to -1. So when you're looking at a parabola, you really need to find the vertex. You'll have a graphing calculator available to you in class to look at one, so you can always tell. Something that's kind of important here is that if you're given x equals y, or ay squared plus by plus c, this is not a function. What this is a parabola turned on its side. And remember in class the other day we said that anytime you see y squared, it's not a function. A circle has y squared and it's not a function. So a parabola that's turned on its side, or is in terms of y, is not a function. So that's something that you need to just be aware of. The next type of function is polynomial functions. And this is in the form of f of x equals a sub n x to the n power plus a sub n minus 1 times x to the n minus 1 plus dot, dot, dot. That means it continues on all the way to a sub 0. I'm not going to write the same thing over with y because it's the same, looks the same. The only thing that's going to change is the y in the front. What this is saying is this is any power greater than 2 we call a polynomial function. So an example would be for f of x equals 4x to the 5th plus 3x to the 4th minus x squared plus 2. And my domain is all real numbers again. And my range varies depending on my function, and you'd have to look at the graphing calculator to help you out with those types of problems. We'll spend some time doing higher order polynomials or polynomial functions later on this year, sometime in December-ish. Should be before Christmas, sometime in December. All right, absolute value functions. This is V-shaped. Okay, so an absolute value function looks something like this. And it's in the form f of x equals the absolute value of ax plus b. That just happens to be, that's just one type of absolute value function. And an actual example, I'm going to use y equals just to change it up. So as you know that f of x and y are interchangeable. The absolute value of 6x plus 2, oops, absolute value, not a parentheses. My domain is all real numbers again, because I can't restrict the values that I substitute in for x. However, my range, I'm never going to get a negative value. It's going to change a little bit dependent on if my function has been moved up or down, but the range will be y is greater than or equal to 0 for the most part. Again, you'd have to look at your graph. Like in this case, the range would be, say that was -2. Everything would have to be greater than or equal to -2. So just know that if you have an absolute value function that looks like this, where there's nothing being added or subtracted on the outside of the absolute value, it's going to be greater than, or it's going to be greater than or equal to 0. But it varies if you're adding a number to the outside of the absolute value. All right, the last is a step function or a greatest integer function. This is probably something you've never seen before. This is kind of cool. It's f of x equals, it's a bracket x, or depending on what book you're using, they might have like a double bracket. Looks like a double bracket. It's got like 2 lines there. And this, when you graph the function, it actually looks like little steps. So it would be like a closed circle, draw a line, open circles. Directly above it, closed circle, draw a line, open circle. Directly above it, closed circle, draw a line, open circle. So that's what it would look like. An example would be f of x equals the brackets x plus 2. And what it actually means is if I have a function and it is just x, greatest integer function x, if I put in 2 for x, the greatest integer, that is not more than 2 is 2. If I put in 2 and 1/3, 2 and 1/3 is 2.333, repeating. Well, when we have this greatest integer function, what we do is we truncate all the decimal values, and to truncate means to cut off. We ignore them because I want the greatest integer that is equal to the number out in front. So again, my answer is 2. I can't get larger than that. I mean, I couldn't round up anyway, but I couldn't get larger than it. I just want an integer, so I would stop at the 2. If I had f of x, or f of x equals, let's see, we're going to do 2 and 3/4. So that would be 2.75. The greatest integer, when you truncate, you cut off the decimal points, would be 2. And the only way I'm going to get to 3 is when I put in 3 for x. So it's going to be like creating little steps. So you're going to go between 2 values. This is my starting point. This is my ending point. For these, my domain is all real numbers again. And my range, I'm using multiple values. It's just not inclusive. However, it is all integers, because my answer always has to be an integer. And in case you don't remember what an integer is, they are positive and negative whole numbers and 0. Okay. Okay. The last 2 parts here, type A and type B, functions with a restricted domain. That means I'm putting restrictions on my domain. And I'm not going to ask you to find a range of these functions. So this is strictly just domain. And whenever you have a fraction, maybe I should put this where you can see it, look for values that make the fraction undefined. So you're going to set your denominator equal to 0 and solve. So for the first fraction, we have f of x equals 1 over x squared minus 9. Well, my denominator is x squared minus 9. And I'm going to take that and set that equal to 0. This is factorable. X plus 3, x minus 3 equals 0. So x equals negative 3 and x equals 3 when I solve that. So my domain is all real numbers except plus or minus 3. Negative 3 will make that 0. Positive 3 will make that 0. So that means I can have every other value except for those two for my domain. Another way to write that is x cannot be equal to plus or minus 3. Okay. The next denominator is simply x minus 6. Set that equal to 0. So x is equal to 6. So my domain is all real numbers again, except 6. Or x cannot equal 6. And the last one, my denominator is 2x. Set that equal to 0. Divide both sides by 2. X equals 0. So my domain is all real numbers except 0, or I can write it as x cannot equal 0. Those things all mean the same thing. Okay, for radicals, find the numbers that will make the number under the radical greater than or equal to 0. So what I'm actually going to do is what's under the radical here is x minus 4. I'm going to simply take x minus 4 and make it greater than or equal to 0. So when I solve, I add 4 to both sides, so x is greater than or equal to 4. And that is actually the domain. Whatever I get when I solve is my domain. For number 2, we have x plus 5 is greater than or equal to 0. Subtract 5 from both sides, so x is greater than or equal to negative 5. So my domain is x is greater than or equal to negative 5. Just be aware that when you have an inequality sign, and if you for some reason are dividing by a negative number, you're going to have to switch your inequality. Okay, the last one here is a little bit different because we've combined the radical with a fraction. And when we combine the two, okay, we have a radical. Oh, there you go, now that it's writing again. A radical and a fraction together. We want to make greater than 0 instead of greater than or equal to 0. So I'm going to simply say that x minus 2 is greater than 0. And I add 2, so x is greater than 2. So my domain is x is greater than 2. Find the range if the domain is x less than or equal to, or sorry, x such that 0 is less than or equal to x less than or equal to 4. For this strange looking function, but this is really all I'm working with is this line right here. And my domain is starting at 0 and ending at 4. Since it's a linear function, I need to substitute 0 in for x and then substitute 4 in for x. So if I am given y equals 2x minus 5, and I put in 0 for x, so y equals 2 times 0 minus 5, y is equal to negative 5. If I put in 4 for x, so y equals 2 times 4 minus 5, so y is equal to 8 minus 5, y is equal to 3. That means my range has got to be between my two answers, which is -5 and 3. So my range is -5 less than or equal to y less than or equal to 3. What I did is I restricted the domain, so I'm only looking between 0 and 4. So I only want the y values that are between 0 and 4 for the x value that it coincides with. All right, sorry that was kind of long. We had a lot to do there. Normally this in class would take me 35 minutes. So good luck.